Hello friends, as I already discussed the introduction of analog electronics, in today's lecture we are going to start with diode. So in diode, I am going to explain the diode basics like forward biasing, reverse biasing and its characteristics. After that, we will go to open circuit test. So why is this open circuit test used? It is used if in a circuit there are more than 1 2 diodes to find the state of diode, whether it is on or off. So while teaching this, I will tell you that. And after this, diode has a rectifier, half wave rectifier, full wave rectifier. In full wave you will have two configurations, center tapped and another one is full bridge. After that we will move on to clipper circuits. This clipper and clamper are called as wave shaping circuits. In clipper circuits you will have series clipper, shunt clipper, two level clipper. So you don't need to analyze all these clipper circuits. By using a shortcut you can answer any of them. Similarly, the same case with clamper. After completion of this, we will go to Zener diode, which can be used as a voltage regulator. So, this is the overview of the topics which I will teach today. So guys, this is the basic representation of the diode. It will have two terminals. This is called as anode, this is called as cathode. See, the practical diode will be like this. The side which have this white color coating, it is called as cathode, and the other side is called as anode. So whenever you see the practical diode, you should be able to identify which is anode and which is cathode, so that you can connect in some circuits. And this is called as p-type, this is called as n-type, and this is called as p-n junction diode, because due to p-type and n-type, a junction will be formed in between. And more details about this junction is not required. Why? Because gate will not ask in detail about this junction. We just need a formula and procedure how to solve the question. So guys, this is the p type of the diode, this is the n type of the diode. For our understanding, I am writing this as positive and writing this as negative. So what is the forward biasing of a diode? Whenever we will apply positive to the p type and negative to the n type, then the diode is said to be in forward biased. So what is reverse biasing? Just reverse of this. Whenever we apply negative to the p type and positive to the n type, diode is called as reverse biased. So what will happen in forward bias? What will happen in reverse bias? Come on guys, you all know this. In forward bias, diode will be in on condition. In reverse bias, diode will be in off condition. So reverse bias, I can represent diode as open circuit. In forward bias, I can represent diode as short circuit. But these are the conditions of ideal diode. In reality, for a diode to be on, we should apply voltage greater than threshold voltage. See, if 0.7 is the threshold voltage, if we apply V equal to 0.1, 0.2, the diode will not become on. But when V equal to 0.7, then the diode will become on. Hope you got my point. So there will be minimum threshold voltage for each diode. So the threshold voltage is 0.7 for silicon diode and 0.3 for germanium diode. See, I have represented the equivalent circuits under practical condition. So this threshold voltage will be representing like this. Why am I representing in reverse direction? Because this voltage should overcome this threshold voltage. It means that this threshold voltage is opposing this original voltage. So I am representing in reverse direction. So this is the practical equivalent circuit. Whenever we apply positive to p-type, negative to n-type, it is in forward biased. The forward biased equivalent circuit is this one. We should write 0.7 volt in reverse direction. If the current flow direction is like this, 0.7 we should write in reverse direction. In some question, he will include the internal resistance also. So how we should write that one? like this. This is internal resistance, this is 0.7 volt. Here positive is applied, here negative is applied. It is the diode equivalent circuit under forward bias condition. So let us see the characteristic. See, this is the threshold voltage. Whenever V is less than threshold voltage, there is no current, I is 0. But whenever V is greater than this threshold voltage, current started flowing through the diode. This is the what we discussed. Now coming to the reverse bias region. In reverse bias region, diode will act as an off switch, you know. So simply we will represent as open circuit. But every semiconductor device will have a breakdown voltage. Like every device will have temperature limits. If we apply voltage greater than VBR, it will break. This is reverse voltage. So in the reverse direction, it will act as an open switch. So we should not go beyond this limit. What happens if we go beyond this limit? Diode will burn. In practical circuit, diode will burn. Yes, it will burn. So we should operate our diode up to here as an open circuit. After this, it is called as breakdown region of diode. Breakdown occurs. So it may be dangerous sometimes. So operate only up to here. See here guys. There is a diode. I applied a voltage of VD. Here positive is connected to P type and negative is connected to N type. So you tell me what is the condition of diode? It will be in forward bias. Assume ideal diode. So if it is in forward bias, the current will flow through the diode, right? That equation of the current is given by this expression, where I equal to Is into e power Vd by nu Vt minus 1. I will explain this expression, it is important. So whenever the diode is forward biased, the current flowing through the diode will follow this equation, right? So I is the current flowing through the diode. Is is called as the reverse saturation current and Vd is the applied voltage. Vt is called as thermal voltage. So actually Vt value will be Kt by Q, where K is Boltzmann constant, temperature, charge of electron, and this value will be nearly equal to 26 millivolt. This is at room temperature. So if in the question he said this diode is at room temperature, take Vt equal to 26 millivolt directly. Next, nu is called as the quality factor. He will give the value of nu. If he didn't mention, take nu equal to 1. Maximum he will mention in the question. So whenever a positive voltage Vd is applied, the current flowing through the diode will follow this equation. Next, in gate he will ask what is the resistance that diode will offer. So if there is a diode, voltage across diode is V, current flowing through the diode is I. What is the resistance diode is offering? Nothing but V by I. So you know what is the voltage. So you can find the current through the diode by this equation. So you can find the resistance offering. But here there is a twist. This resistance will be different when the applied voltage is DC and when the applied voltage is AC. See, when the applied voltage is DC, V will be constant, I will be also constant. So this is called as static resistance or DC resistance sometimes. But when the applied voltage is AC, V will be varying constantly. See, if I applied this voltage, I cannot say that this is V, this is V, this is V. It is varying constantly. So which way should we take? Think. I am telling the answer. So we should take dVd by dId. This is called as the AC resistance or dynamic resistance. Dynamic or AC resistance. and its value will be equal to nu Vt by Id. Or you can find from here. This is Id. Differentiate Id with respect to Vd. What you will get? Did by dVd equal to, neglect this minus 1 because Is will be very low. Is into 1 by nu Vt into e power Vd by nu Vt. And see, this Is into e power Vd by nu Vt, it is again equal to Id. So from this, dVd by dId equal to nu Vt by Id. What is nu? He will give in the question. What is Vt? 26 millivolt. What is Id? Current flowing through the diode. So from this you can calculate the on-state resistance of diode. So what we learnt? There will be two types of resistance diode will be offering. One is DC, one is AC. DC resistance is always V will be constant. So I will also be constant. You can calculate directly V by I. That is called as static or DC resistance. But while coming to AC, voltage is varying constantly. It means voltage is varying with time, every time. So we cannot say that this voltage, this voltage, this voltage. We don't know which voltage should we take. So we will take dVd by dId. This is called as AC resistance or dynamic resistance. So how we calculate? By differentiating this Id and by taking reciprocal. We got nu Vt by Id. This is the on-state resistance of the diode. So if you observe this question, in this he given that silicon is forward biased. Find DC and AC resistance. It is 1 mark IES question. So for DC resistance, what you should do? See, if silicon diode is in forward biased, what is its equivalent circuit? Since this is the direction of current, we should draw voltage in reverse direction. This is 0.7 volt. This is 2 volt. This is 1.3 K. Now, if we observe what is the voltage across the silicon diode? 0.7 volt. So what is DC resistance? V by I. V is 0.7 volt. What is I? So I is nothing but 2 minus 0.7 by 1.3 K. So this is I. What is the value we are getting? 0.7 by I'm getting 700 ohm DC resistance as. Next, how to find AC resistance? What is the formula given for AC resistance? That is nu Vt by Id. If nothing is mentioned, take nu as 1. But here he mentioned that it is a silicon diode. So generally nu value will be 2 for silicon, 1 for germanium. Remember this. If silicon is mentioned, take nu as 2. If germanium is mentioned, take nu as 1. If nothing is mentioned, take nu as 1. So here he mentioned specifically silicon. So take nu as 2. So nu is 2. What is thermal voltage? 26 into 10 power minus 3 by what is ID? ID is here you got ID as 1 milliampere. 1 milliampere. So I'm getting this as 52 ohm. So if we give a circuit, this is the procedure to calculate AC resistance and DC resistance. So is this okay, guys? In this video I discussed the forward biasing of diode, reverse biasing and its characteristic, equivalent circuit, on resistance, off resistance and a problem on it. So if you like my explanation, do like, share and subscribe to my channel, guys. So what will happen is, if I want to do more videos, I need some motivation. If you subscribe to my channel, I will get motivation and I can do more videos. So I will think that if someone subscribed to my channel, I will think someone are getting benefited because of me. So I will get more motivation, because that is the motto of this channel. So subscribe to my channel, guys, and do like my Facebook page, follow on Facebook, Instagram. The links are provided in the description below. Thank you. In the next video we will discuss open circuit test, because here there is only one diode, no problem. If there are more than one diode, like 2 diodes, 3 diodes, 4, 5 diodes, so there we need some test, that is open circuit test. I will teach in the next video. It is very easy, don't worry. So subscribe to my channel, guys. Thank you.